Welcome, everyone. We're very happy to see you here. We've got a webinar today by Francesco. He's our developer advocate, and I say he's the Superman of data analytics. So we're very happy he will tell us all about metadata today. So I'm going to hand over the microphone, sort of speaking, to him, and I hope everyone will enjoy. After this webinar, we'll of course share the recording as well with you. So if you need to, you can share it with colleagues or friends, and enjoy. Thank you.
Thank you very much, Leonie, and thanks everybody for joining in today. I have a couple of things to say before starting with the webinar. I believe this topic is close to me because I've been playing with data and metadata and data lineage in all my career. Part of this is because before joining Aiven, I was in the data and analytics space, and I was creating metadata layers to enable business people to access database data. So understanding and knowing where a data point comes from has always been one of my passions. So I'm really happy to be here today to talk about this with you and how it can apply to the modern world of data ecosystem, of the data ecosystem. So let's start this talk about create the data lineage across technologies. Let's start by understanding why we need to do that. And, if you are some sort of kind of small, medium, or a startup, there are chances that, all your data is sitting in a unique database. Your applications are pushing the data into the database, and your analysts, your stakeholders, your business stakeholders are able to somehow generate SQL queries on top of the database to extract the data. So why this is good? It's good because all your data assets are contained in a single location. And more or less every database offers some sort of, GUI or web UI or some other tools that allow us to browse all the data assets that we are included in our database. For example, we can browse the list of tables, the list of columns, what column type we have, what is the meaning of a column. But usually we don't stop there because that's only part of our data assets. Another very important concept that we have together with the data is also which users we defined in the database. We can have different users, and each of the users will have somehow different privileges. For example, I'm Italian, so people might give to me only the view of the Italian data of the company, while I believe Leonie is based in the Netherlands, and she will have that part of the company. And also, it's all about grants. So I can insert data, I can only view data. Also, depending on the database, we can apply some sort of advanced filtering, like the filters that I was discussing before. So the beauty of having everything in one database is that we can use a UI to find all this information, to browse all this information. The problem now is that how many companies do you think are in such situation? I believe, from my experience, almost zero. Because yes, you start with a database, but then someone else will probably have the need for some streaming data, and you add Kafka on the side. Then some other team will need some advanced text search capability, and you add OpenSearch. And maybe, why not, a little bit of Cassandra, a Flink here and there, some lovely Postgres, and then other tools again. Because you want to give to every single team the perfect tool to solve their problem, to execute their job. And you see in this picture, this is something typical that we see across companies, a multitude of different tools. Each of them are used for a single project or a subset of projects, enabling the teams to really execute as maximum of their power. But now the problem with this approach is that it's hard to have the global map of all our data assets. We don't have a clear, unique GUI that tells us we have these tables, these users, these grants. It's all scattered across different tools. And with this, it comes some risk. The first risk that it comes is that we can lose information. Not knowing that another team did a project about cleansing customer data, it may be a problem for my company. Also because if I don't know about the other team effort, there are high chances that I will start a new project trying to cleanse the data again. So duplicating the effort. And once you are duplicating the effort, you are probably also duplicating the amount of money spent, because you will have to dedicate another team to do exactly the same job. Or maybe you are hiring an external consultancy firm to do the same. But money and time, it's a risk. But there is something worse about duplicating the effort. And it's coming from my experience being like in 15 years in the data field. If you allow two different teams to more or less do a similar project that has similar objectives, but those two teams, you don't allow them to talk with each other, well, I can ensure that the result will be completely different. You will have conflicting data. Maybe, one team was cleansing data in one specific way and the other team took a little different approach. The end result will be different. And now again, you are not creating one unique view of the company for like clean consumer data, you are creating multiple views. But again, in my opinion, duplicating effort, losing information, conflicting data are problems. But the major problem in this space is not having the overall control on who can access the data. So it's easier for people to get in. This could be, an external person being able to access some of your private data sets. Or it could be also other teams that shouldn't have access to this specific data set, but because you cannot really understand where this is going, who can access what at each step of your data pipeline, they will have access. And this happens more often than not, because now our data pipelines are a little bit complex. Now you may think, Francesco, you are probably creating a problem out of nowhere because you needed to talk about something. But the reality is that all this problem have been addressed by the data industry for a long time. One specific problem, which also goes in the title of the talk, is data lineage. Data lineage is the ability to follow a precise column, a precise data point across the different technologies. And again, I've been in the data space for a long time, and I've been using tools like, informatical talent to create those data pipelines. And if the only tool that you are using to create the data pipelines is just one, well, those tools will always have a way to provide you some sort of data lineage. But the problem is really on another level, where we have multiple tools that are allowing us to create data pipelines. As in our example before, we may have, the source of data in a database, then an Apache Kafka connector to take the data into Kafka, then a Flink job on top, and then a sync to, Amazon S3. We are talking about like 5 different technologies, and it's really hard to create a data lineage across them. Another industry term regarding this kind of problem is impact assessment. We need to understand what is the impact of a small change. Again, in the old days where we didn't have this information, impact assessment was usually done by do we need to understand what happens if we remove the column? Let's remove the column. If nobody complains in the next month, then we did something good. But with the pace of change that we have in nowadays companies, we cannot afford 1 month of waiting time. We need to know upfront if a change that we are making is going to destroy some data pipelines down in the line. Another interesting aspect, which is always related to data lineage, is also a security assessment. Because together with understanding how a certain column is mapped across various tools, you also want to know which actor at which point can access your data pipeline. Because you don't want someone from outside or some other team to gain visibility that they shouldn't have. But then we have what I call the final monster, which is basically all the 3 problems that I stated so far, plus something else. This final monster is called GDPR. And with the GDPR, we don't have only the technical challenge of, understanding who can access what and where. We have also financial implications if we don't manage to reply properly to GDPR queries. So I believe you started this Wednesday without probably having any problem in our mind, and I started giving you a little bit of a little problem. But hey, none of the things that we discussed so far is new, right? We have been discussing about data lineage, security assessment, impact assessment, and GDPR for quite some time. How did we solve usually these things? Well, most of the times we use it to rely on documentation, right? Because almost all the time documentation is there, right? Maybe not. I believe relying on documentation to solve this kind of data lineage, impact assessment, security assessment, or GDPR queries exposes you to a lot of risk. The first one is that reading or writing documentation is really complex because you are maybe reading a document who was written about 15 years ago by a colleague who already left the company. And maybe it's about the technology that you don't know. And it's hard to find information about what you're looking at based on that. Also because, reading documentation is really time consuming. You don't really want to parse 200 pages of documentation in order to find why a certain column was transformed or how a certain column was transformed. Also because documentation has the tendency of always piling up. Every time you create a new project, well, here is the other 200 pages of documentation. And it's always adding up and up. But again, spending time on complex, time-consuming, piling up documentation is not as bad as finding yourself in a place where there is no documentation at all. Maybe because the developer is still testing the solution, or maybe the developer just pushed the solution to production and didn't have the time to write the documentation yet. Or even worse, because the developer pushed the production and left the company. And now you have a perfectly working black box in your organization that is working, but you don't know anything about. So how can we fix this? Well, documentation is not the solution. We cannot rely on documentation. But I have a very good news for you. The solution is not far from where we are looking. It's not far from where our data assets are. The solution is looking into what we call metadata. And metadata means looking beyond the data, understanding more about the data. Metadata is the data that allows us to understand the data. If this doesn't mean a lot to you, let me give you an example. If I show you this kind of table, can you tell me what this table is about? Probably not, right? What if I show you a little bit more information. Now you can tell me, well, there is a ranking, there are some countries there, there is a score which still we don't know anything about, but then there is GDP per capita and social support that are metrics usually associated with well-being. Well, just with this information, you probably almost got it right. This is the World Happiness Report. It's a report that tries to rank all the nations by the degree of happiness related to some of the metrics which are measuring the well-being. The top one is Finland. Aiven, my company, is based in Finland. My Finnish colleagues seem pretty happy. We have sometimes discussion about food, but they still seem to be pretty happy. So going back to our topic, what did I add here? I add the column headings. The column headings are the metadata. It's the information that allow us to understand our data. And if we do one step back, this is exactly what we were looking at in our database. In all our database GUI, we were reviewing metadata about the database tables, the users, the filter, the grants. But now, again, our solution, our situation is way more complex. We just don't have one single GUI. And here is where, using open source tools will put you one step in front of the others. Because with open source tools, not only the data is in some sort of open format, but also the metadata is always there, always available. You will never have the chance of, having part of the metadata in a hidden schema that you can access only if you pay an enterprise fee. With open source, both data and metadata are always there. Let me show you an example. We have we have a definition of a Kafka topic. And just by the definition, we can understand, for example, the topic name, the state, the retention hours, bias, the replication, the partitions, all useful information. Let me give you another example. This is a table definition in Postgres. And just from this view, we can see that I have a public schema, a table called animals with 3 columns, ID, name, and age, with the data types as well. So with just a first glance, we understood that we can parse the metadata and we can get a lot of information about the world that is surrounding us. But also with just 2 examples, I've been showing you a quality or a problem with just parsing metadata. The Kafka topic was a JSON representation. The Postgres table, it's a table format. But even more, those 2 tools, they don't speak the same language. They have different entities. So for example, if we talk about a database, we will have the entities of the database itself, the column, the table, the schema, the user, and the permission. If we move to Kafka, well, there is no database in Kafka, and there is no column in Kafka. But in Kafka, we have, the broker, the topic, the ACL, the partition, the user. If we move to something else, which is in our data assets, like Grafana doesn't have the concept of partition or topic. But in Grafana, we talk about data source, dashboard, and visualization. So all these different tools will speak different languages, will have different entities that don't talk to each other, possibly. And, the problem is that we have a huge variety of tools, and we need to collect all the information about those tools and their related entities. But our work doesn't stop here, because we also need to collect all the interactions across our tools, because that will give us our full data pipeline, our full data lineage. So the problem now is that, we may think, okay, let's collect the data and let's try to push to a relational table, but we cannot put all the different objects, all the different entities into a standard shape. They will have different shapes. This is when we need to do one step back and probably look at the problem from a little bit far away, adding a layer of abstraction in the middle. And this layer of abstraction is given us by the graph theory. The graph theory is a way to simplify the reality, because with the graph theory, all the world, everything, can either be a node or an edge. A node is, myself, my t-shirt, my microphone. The edge is something that connects two nodes. So I'm wearing my t-shirt, I'm talking at the microphone. Let me give you a deeper example. Let's say that we navigated our world and we see in our world a node with ID body. The ID is what makes the node unique across our universe. The beauty of each node is that we can not only assign an ID, but also assign a set of other parameters, other attributes. So I can say that the ID, the body node, is a dog. It makes bread, 7 years old, and the preferences are food, squirrel, and playing ball. Can I find some other node, in my world? Well, if I turn a little bit, I have a colleague called Elma. He's a human. So check here. I'm reusing the same attribute species, so will enable me to query all the nodes with using the same attribute, but the rest of the attributes is different. I don't have to fix all the columns of my entities. Every entity can have a different set of attributes. Then we have two nodes here. Let's create an edge. The edge could be from body to Elma, and also the edge can have attributes. So the edge in this case says that they are friends. The friendship started in 2015 and it's very strong. The edge can also go from one place to the other. So it could go from Elma to body, saying that Elma is friend of body, or from body to Elma, saying that body is friend of Elma, but we don't know about Elma, or it could be both directions. So let's take this example and move it to our kind of data lineage world. Let's start by saying, what if we have a database called AnimosDB, which contains a schema which is called public. In the schema public, we see a table called dogs, which has 3 columns: name, ID, and age. And by the way, the table can be seen by a user called vet. Now, you probably have thought at all these items within a relational database, in a relational world. But now this is an exact mapping into the graph world. All these items are nodes, and the edges that connect them is it contains or is it contained if we revert where the arrow is pointing. But again, you might say here, well, all you're doing is changing the database UI into a graph database, into a graph representation. We are not gaining a lot out of it. But let me show you one trick now. Let's start from the same situation of database schema table. What if the table itself is pointed by a data source, which is used in a dashboard that can be seen by a user? Now, without changing anything in my abstraction layer, I'm talking about 2 different tools. I'm talking about a database table and a Grafana dashboard. That's the beauty of adding the abstraction. We can still keep or think about nodes and edges, also if our solution now spans across different technologies. I believe now you are starting loving the idea, and you are maybe interested in how you can apply this to your case. So let's try to do it. First of all, what we need to do is we need to get the data. And the world could be a beautiful place if all the tech tools out there could offer a standard interface to export all the data. But usually they don't. So you will have some technologies that offer, for example, a REST API like Kafka Connect that you can call in order to get the metadata. For some other tools like Postgres, well, you will need to use a particular client to run some queries and extract the data in a tabular format. So depending on the the technology that you're using, you will need to select one option. What we can do here is, script all of these things using, for example, Python to extract via REST APIs or via CLI what is needed. But then the next problem is, how do we join the data? Because as I said before, different technologies are talking different languages. So what we may call a table in Postgres could be actually part of a query or a Kafka Connect definition. So how do we join the dots? Also because, it's not only about different languages. Also, different tools can call different endpoints in a different way. Just think about the difference between an host name and the IP address. I could have the host name defined in my Postgres configuration. On the other side, I could reference to that Postgres database with the IP address when I query it. Again, this starts to be challenging, and you may think that there is no solution. But again, good news, don't despair, because part of it is already done. It's already done with what we call the Aiven metadata parser, which is a fully open source tool that we started developing within Aiven. What we are doing with the Aiven metadata parser is we start parsing a lot of the tools that we provide as a managed services. So for example, we provide Kafka, Postgres, Grafana, OpenSearch, MySQL, Flink, all available to you as managed services, and you just have to do a couple of clicks and you have a fully working Postgres or Kafka available in a couple of minutes. So what we did is, let's try to understand what's going on within our services, and let's try to parse all the metadata or part of the metadata of our services in order to build this kind of global map of the data assets. How we are doing it? Well, you are using the standard REST APIs or CLI that the tool exposes. We are also using the Aiven client, which is a way for you to manage via command line all your Aiven assets, but it also exposes a series of interesting Python functions that we can use in order to retrieve all this metadata. So let me give you an example. Let's say that we have one table called animals, which has a single column called ID. Let's see how our metadata parser will create the data lineage. First of all, it will create a node for the PG service, for the Postgres service called animalsdb. Then within the Postgres service, it will create an ID, a node for the schema public. Check here. What we are doing is, in order to create a unique ID, we are concatenating what is the item now, schema public, with what it is contained, PG animalsdb. This will allow us to have, several Postgres services containing the public schema, but still keep all the nodes unique because the nodes are different. Then if we go one layer down, we find the table animals. And again, check here, we concatenate the table animals with the schema public that it contains the table. And then we define the column ID. And again, we concatenate all the interesting information and we add all the qualities of the column ID, like the type, database column. It's an integer, max length is 32 and is not nullable. And we can add custom attributes at every layer of our hierarchy. So this is a little bit of an info on how we retrieve the data. What we do next is we also do some sort of smart parsing, because in order to have all the information, we need to extract the data in a smart way. For example, the problem that I was showing you before, we don't need to extract only the single host name, but we also need to extract all the potential aliases that, for example, a database is known with, all the IP addresses that are behind the database. With Postgres, for example, you can have a primary and a read-only replica. What if a Grafana dashboard is pointing to the read-only replica? We still want to connect all the dots in order to understand who can access our tables. So we need all this kind of information. Also, what we need is to map any external endpoints. For example, you may send your metrics to Datadog. Still, that is part of your data journey, of your data assets, and you want to map that in your overall graph. Then what we do is we use, as I was showing you before, standard semantics that will make easier to create unique nodes, but also to find nodes if we need to. For example, if we have a Grafana dashboard that points to a Postgres dashboard, a Postgres table, we may want to check if the Postgres table is something that we already have in our graph. And if not, we can create it. The last bit that I want to show you is about link discovery. So we need to not only parse the single technologies, but we need to create connections across the technologies to have the overall map. And this is specifically true for tools like Kafka Connect, Grafana, or Flink, that they don't work in isolation. Kafka Connect will take the data from a place to Kafka or from Kafka to another technology. Grafana will query other technologies, and Flink can work with other data coming from other technologies as well. So how do we connect the dots? And again, what I'm going to show you is an example on how we do that. Because if you check this Kafka Connect configuration file, this is a configuration file that you set up if you want to take the data from a database into Kafka using the Debezium connector. If we start parsing this Debezium connector, what we can find is that the source database hostname is my database host.aiven.io. So what we can do is, since we use standard semantics, we can check in our graph if we already see a node with that specific hostname. Then we go back to parse again our connector configuration. And the last parameter, table include list, contains public animals. Public animals will be the schema and the table name. So again, we can go back to our graph and check if there is a node containing public animals. And this solves pretty much what we are pointing to on the Postgres side. What about the Kafka side? Well, the connector will be deployed on a certain Kafka instance, so we can find the node or create the node. And then, again, by reading the documentation, we can also know that, for example, the target topic in Kafka will be the concatenation of database server name and table include list. So we can also create a node which allow us to basically bridge the gap between the two technologies, because we go from the table in Postgres, which is hosted in a database, all the way to Kafka and the Kafka topic where the data is landing. Now, this is how the Aiven metadata parser works. And since the Aiven metadata parser is generating a graph, the output should be something that graph tools can understand and parse. So therefore, what we do as part of the Aiven metadata parser is we produce two files, a dot file and a GML file, which are the format that are usually used in the graph space to share information. But then we do a little bit more than that. What we do is we generate a static file, which allows you to browse and click and check and go over with the mouse all the nodes and the edges to understand how your data flows. But, this is exceptional for, our demo. but you really don't want to have only the ability of going over and moving all the nodes a little bit left or a little bit right if you want to, for example, understand who can see your data. This is beautiful for a demo effect, but point and click is not something that we can work with. What we also did as part of the metadata parser was to create a simple dash app that allows you to filter only all the nodes for, a specific node type, but also allows you to say, I want to know which nodes are connected to a particular node. Let's say I'm interested in all the nodes connected to a table called pasta eater. This will basically show you all the nodes that are connected to it. Will give you all the data lineage across the tools. It's still very simple, but it gives you the idea of the power of having this data and being able to see the overall map of all your data assets. Should I do a little bit of a live demo? Let me try. So I created in my Aiven project it's not simple, it's not complex, it's a mix of complexity, including a lot of the technologies, not all, but a lot of the technologies that Aiven offers. So I have Redis, Kafka Connect, OpenSearch, Grafana, MySQL, Postgres, Flink, and Kafka. And each of them have some sort of data assets within them. So what I can do here is I'm in the metadata parser. I can call the main.py, and this is starting reading from my project, first of all, which are all the services that I'm running there, and then parsing each of the service. So you see, I'm parsing, as of now, Kafka Connect, and then at the end is writing the .gml and .x files. Now, together with this, what's the good point is that we generate a static HTML file, which is this. Let me refresh it. Where we can see all our data assets scattering across different technologies. So I can see them Redis, Postgres, OpenSearch, and all the rest of the beauties. What I can do is I can also execute the app.py, and this should start my dash application. And okay, this is not working as of now, but it will give me the overall look of this, exactly the same beauty that I was showing you on slides. So it will give me the ability of querying only certain nodes, going over the nodes, or just filtering for a specific node and understanding all the other nodes which are attached to it. So if we now go back to the list of questions that we had at the beginning, can we solve data lineage with this? Well, you could see data lineage in action there. Can we solve impact assessment? Well, maybe try to remove a node and check how many edges have been removed and analyze the impact, analyze the importance of those edges. Can we do security assessment? Well, since we map users as nodes, again, it's just a network query. Can we do GDPR queries? Again, it's just a mix of all the things that I said before. I want now to give you a little bit of look of what's coming next, because it might be interesting for the metadata parser future. As I said, this is a fully open source project, so you can contribute to it. First of all, what we think we want to do is we want to increase the tool's coverage. So for example, as of now, we don't parse ClickHouse, Cassandra, or M3, and we may want to do that. We also don't do a lot of parsing. We do a basic parsing of all the services, but we could do more. For example, we parse only a couple of Kafka Connect connectors. We could parse all the connectors. And then another addition, as of now, we are relying a lot on the Aiven client and the Aiven tools, but we are querying open source data technologies. So you could, for example, give us the list of endpoints that you are wishing to analyze. And based on the endpoints and the credential that you submit, we should be able to do pretty much the same on top of any, for example, Apache Kafka, no matter where it's hosted. So if knowing who can access a precise data point at every step of your data pipeline is something that doesn't allow you to sleep at night, well, start using the metadata parser and just reply to that question with a simple or maybe a little bit sophisticated network query. I want to leave you with one link where you will find both the slides of today's session, but also a set of links to know more about the metadata parser and how you can solve the data lineage problem in your case if you're using open source tools. I hope you enjoyed the last 40 minutes, and I'm now here for all the questions that you may have. Thank you very much.
Thank you so much, Francesco. We do have questions. We've got a question. How about data lineage through computed variables / columns? Do you need more explanation with that?
Yeah, let me rebrowse the questions. So what about data lineage? Sorry, can you rephrase it or restate it?
How about data lineage through computed variables or columns?
Okay, so that's an interesting question because, for example, with SQL, you could change the shape of the columns. Or with Kafka Connect SMT, single message transform, you could do the same. There is where I believe it gets a little bit tricky, but I believe I saw tools out there which are able to parse SQL, for example, and understand how a certain column is shaped. Or like the simpler approach could be only to base that on a table level without tackling the column level. So depending on how much complexity you want to add to the solution, you could go to single column or a table level if you want a simpler solution. As of now, the metadata parser doesn't really track on column level, but the aim is to go there as well.
Thank you. And does it work only with Aiven, or does it extend to technologies that Aiven doesn't provide?
So as of now, it works with Aiven, and it relies a lot on the what we call Aiven client, which is a set of it's an open source Python project which allows you to query with Python all the Aiven resources. But again, for example, you could take the code for Postgres and run it in any Postgres, and it will still work. For Kafka, maybe we are relying a little bit more on the Aiven clients itself, so you will need to find what is the alternative open source REST API. But some of the technologies where we do just query, which is, I believe, MySQL and Postgres, the tool is already working with any other technology. Sorry, with technologies which are not hosted in Aiven. The other interesting bit of the question is, can it work with other technologies that Aiven doesn't provide? And I believe since the idea behind it is to give this abstraction layer, you can possibly write your own plugin. For example, do you have technology Y or technology Z that you are interested into passing? You can create your plugin for that technology, but still benefit of the metadata parsing that we can do on the rest of the Aiven technologies as well. And, it's the tool that's there, and we are happy if you contribute to the tool itself, even if the target technology doesn't sit within Aiven.
Thank you very much. If there's any other questions, now is the time to type them. I also have a poll set up for you, Francesco. Do you still want to ask that question?
Yeah, I believe that's a good time. No, I believe it's a good time. So the question is about how many data technology does your company use? I believe just one is, I don't think we will hit a 0 ratio. My idea is that most of the times it will be at least 6 technologies. Maybe 1 to 5 if it's an early startup, but most of the time it will be more than 6. And about that technology,
40% voted.
Yeah, about the data technology, I mean, it's not only the database where you store data, it's also the analytics tool that you use to retrieve the data, because that's part of your data assets.
Cool. We'll leave people to vote for a moment. We've got one more question. Do you handle collisions between private network addresses in 2 different zones?
Potentially, yes. I didn't try it with such complex scenarios. But again, it's all a matter on how you define nodes and potentially, okay, so I believe the answer there is if you have, let's say, 2 Postgres which have the same IP over different networks, then what I would do is not only add the IP address, but also add some information about the network itself. So when you do the lookup of the potential source of a Grafana dashboard, for example, you do the lookup both on the network name and the IP address.
Thank you very much. I closed the poll. Not everyone voted, but we can see the answers here. So,
well, there are still people with 1 to 5, and I believe it's relevant because a lot of the time you can do pretty much all you need with a single, for example, backend database, and then you use a couple of tools to do a little bit of transformation and a little bit of display of the data. But yeah, I believe the just one option is what I expected. So 0% of people are just all the data in one single solution.
Cool. Well, with those last results, we'll close this webinar. I want to thank you very much for your very good talk. It was very clear. And if anyone has any questions, feel free to reach out to us or to Francesco. You can also see his contact details on the bottom. And we hope to see you again in the future. Have a lovely day.
Thank you very much. See you soon. Bye-bye.